So if you change it to ask, it just means you're going to be able to put your own values in. Once per year, we already looked at that. Twice per year. What if we jump ahead to, what would 6 times per year be called? Once per year is annually. Twice per year was, what was it called? Twice per year was called semi-annually because it's every half year. 6 times per year, what is that called? What's it called? It's every 2 months, right? Yeah, I guess you could make up a word like that. But every 2 months they would call bi-monthly. Every 2 of something means bi something. Every half of something means semi something. 12 is obviously monthly. What would happen if I did it 2 times per month? Number 1, what would the number be? And number 2, what would it be called? Twice per month? How many times in the year would that be? Twice per month? You know this. Twice per month? 12 months? 24? What is that called? It's happening every half month, so it's called semi-monthly. If it's happening every half of something, you know, like a half circle is a semicircle. Every half month is semi-monthly. Some of you might get paid semi-monthly. If you get paid on the 15th and the last day of the month, you're getting paid semi-monthly. Probably more of you get paid bi-weekly. What's bi-weekly? Every 2 weeks. How many times in the year is that? 26, right? Every 2 weeks, bi-weekly. If you're getting paid bi-weekly, you get paid every other Friday or something like that. It's a slight difference. Now, I'm a little bit off of what I'm supposed to be talking about here. We're supposed to be looking at what's happening with these values here. Is it getting more and more every time I increase this? 52. Is this going up? I was saying, are you going to be up to millions of dollars? Does it look like you're going to be up to millions of dollars? No, right? It looks like it's sort of slowing down, right? So we're going to delete a bunch of these. We're going to get to bigger and bigger numbers here. Every day, 365. Every hour, 365 times 24. You can enter the arithmetic in there. You can let it do the work. What would this be? Let's skip ahead here. 365 times 24 times 60 times 60. That's every second. Well, what does it look like is happening here? Every second, we're not up to millions. We're hardly above what we were for every half month. How would you describe what's happening here? If we looked at the graph, what is happening? I'm going to set up a graph here, even though it doesn't make sense to look at a graph that's a continuous line. When we had this is 1, 2, 3 here. When we had once per year, I had $2. When we had twice per year, I had $2.25. And I skipped ahead here 12 times per year. It looks like it's doing this, but what's happening? Actually, I should put the 3 higher because did it even get up to 3 yet? Didn't even get up to 3. It's leveling off here somewhere. Okay, there's an upper limit on the thing. This function has an upper limit to it. And what did it look like it was about here? It was in there somewhere, right? Right now we're up at 2.718 something, right? It was about that. There's an upper limit to this function. If you look at the graph, it's going to look like exactly like that. Even though it doesn't make sense to have a smooth line, because it doesn't make sense to talk about compounding 1.5 times a year. In the context we're looking at it as, it actually should be disconnected discrete dots. But if we just look at it as a function like this without the context, you can have this smooth line. This has an upper limit here. Upper limit is approximately what? 2.7183. Do you want me to really convince you? We're going to go back to this thing. We're going to put in some higher numbers here, like with a whole bunch of zeros. 6, 7, 9, 10 maybe. Look at that, you can hardly tell the difference. You can see the difference if you go to this, right? But now it's not different till like the 6th decimal place or something like that. How about if I just get smart here and instead just enter it with exponents? We learned about exponents in grade 8. We can finally probably truly understand them in grade 12. It's a theoretical kind of thing. 10 to the power of 12. Roughly that, right? Again, here there's some slight differences, but now it's like the 10th decimal place. It is leveling off. Do you believe me? What's going to happen next year? 10 to the 13th. Uh-oh, what's happening there? Did I lie to you? Did I lie to you? I did not lie to you. Texas Instruments ripped you off. That's what they did. They sold you a calculator that can't deal with things past there. This is calculator error. I mean, we can give Texas Instruments a break because think about what it's doing. It's calculating this. You're asking it to calculate 1 plus 1 over, well, I'm asking it to calculate 1 over, and one more 0 here actually, that, right? To the power of that, right? Can you comprehend what this number is? Like, that's such a small number. It runs into rounding issues, right? Because what is this very close to? 0, right? It's essentially 0. And this is such a high power. Think about how many times you're multiplying it. It's running into the limit of what it can do. That doesn't mean that it doesn't have that upper limit. The upper limit of this thing is that value right there. If you really want to push it, what you do is you go to like 10 to the power of 23 or something like that, then it really has a problem, because look what it does. Because what it does then is it says, well, there's so many zeros here, this is basically 0, let's get rid of it. And it doesn't even matter what the number is out here. It's 1. So it's calculator error. We're going to write something down here. This function here has this limit, okay? Let's make some space. You definitely want to write this down. The limit of the function, we can write it down, right? The function 1 plus 1 over x to the x. The limit of that function as x becomes larger, I should say greater, just to be clear. Greater and greater. Without bound. What does that mean, without bound? If something becomes greater and greater without bound, how high is it going to get? Infinity, right? So I mean, we could say it the other way, as it goes towards infinity. Is what was the upper limit? Approximately what? 2.718. It's approximately that, or what number is that? What would you guess that number is? Take a guess here. It's that number, okay? That's the number. E, that's if you have an E button right here. This E is a number like pi. It's a naturally occurring number. Nobody just made it up and said, oh, I think we'll call E 2.7182818. It looks like it has a pattern. It doesn't. It's like pi. It's irrational. It never repeats, never ends. It's a number that naturally occurs in exponential growth here like this. Or E to be exact. Okay? The reason I'm showing you this is I want to talk about what limits are. That function has a limit. It means the bigger you make this, okay, the bigger you make x, the closer this comes to that line. If you allow x to become infinity or approach infinity or get bigger as much as you want, you say the limit of that function is e. With symbols, this is how you write it. Mathematicians like to make up symbols because they're lazy and they like to confuse people. You know, when you look in the paper these days, or not in the paper, in flyers, and they're selling laptops and stuff, I notice when it's back to school, they always, you know, on the screen of the laptop, different times of the year, they have different things. Like in February, they have Super Bowl images on every TV. In April, they have hockey images, Stanley Cup playoffs. When it's August and September, they have back to school things. And what they have a lot of, I notice now in Future Shop flyers, is they have some guy writing on a blackboard, and it's all this crazy, really complicated looking stuff. This is always one of the things they write, limits, calculus. They also write like organic chemistry and crazy stuff, but they want to look really like they're smart. This is, as soon as you start writing limits, people think it becomes complicated. It's not. It's basically this. Do you know how you say the limit of in shorthand? Do we have to wait till next time for that?
Yeah.
To be continued.
Oh, come on.
To be continued.